Hello, hi, good morning, everyone. My name is Ken. I am from CADVision. I'm a business user of Johor branch. Thank you for coming today for our webinar, CADVision webinar. So I'm glad to be here with you today. So today we will share about SolidWorks MBD. This is an add-in product for SolidWorks. I think most of our attending today all is a SolidWorks user. So let me share my screen first. Yeah. Okay. Okay, before I start this SolidWorks MBD, let me share about one process to you. The machining process is more easier uh, to to explain this SolidWorks MBD. So the first thing that normally you see this aluminum bracket is something we call donut. So how we want to do this? Normally, especially for SolidWorks user, all the 3D people here, they will create a 3D model, of course, yes, then set up in the machine, machining, turning, whatever, and finally they come out the product, this aluminum bracket. This is a very normal process that every day you all do. Okay, and come out the 2D drawing, and this 2D drawing to let the QC people or let the production people to measure. But this is a 2D drawing. But in the model is 3D, the part is in 3D. Why not? Do you ever think that this 2D drawing come in the 3D measurement, something like this? Because because a lot of the dimension is missing in the 2D drawings. A lot of people they doing 2D drawing is just a normal 2D drawing, traditional 2D drawing. They send out to the production, but they don't know the dimension accurately. So let's say I give you an example, this 3D model. Then normally the engineer will do until then give a top view, side view, right view to the 2D drawing. What if the 2D drawing is something like this kind? It's a many view, not like the donut. Just the donut is very simple. That's why it's okay. But what if one drawing you have a many view? This one around 11 view. Some drawing will go to 18 view, go to 20 view, just inside a one drawing. How long you want to create this drawing? Some engineer maybe say, yeah, for me it's easier, very fast. I am very good in engineer. I'm working for 10 years. So for me, this drawing is no problem. What if one day you need to create 50 of this drawing? Yes, for 1 to 2 drawing, of course, very fast. But what if for 50? Let's say I share my experience past 10 years ago. I think it's 12 years ago. I am also a designer for a company. I'm doing a lot of the drawing, and I have many departments. So my department is design and programming. So and also got CNC lah. CNC machining department is not under me, but I am the people who do the design and also doing the CAM. So per day I have to do a 50 drawing, at least 50. And a lot of the new project come in, and I think 10 years ago, very good market lah. Every day non-stop. So that's why I have a lot of drawing I need to do. I can share with you what is my like and what is my dislike. I like is doing design. I like is doing programming. What my dislike is, I very hate to create 2D drawing because 2D drawing take a lot of time. When I after design, then I 2D drawing maybe hold my time spent on the 2D drawing is about 60 to 70%. So how I solve this? Because every project coming in, we have a lead time. The lead time for design department always the shortest. Always very short to us because the production everyone is waiting us. We are the first. So how I solve this issue? So the first thing, of course, it's OT lah. Everyone very love OT. I also love OT. I work every day for 2 years. I work every day from morning to night because of solve the drawing issue. Then secondly, how to solve the issue? Even how many OT you still cannot meet the lead time one. So I just plot out all the drawing. I point out, but I I depend the quality checking to another department. Means because of I want to meet the lead time. So whatever I can point out in the drawing, I just send to the production. I just send to my vendor, in outside the outsource the subcon. So I assume or I expected the production department will come back to me to clarify. Ken, your drawing is wrong. Here is there. Can you show me? So I think something like this, then okay lah, I meet my KPI, my plan already, my drawing already sent out. Then I find out the problem is the people who coming in to find me again to show me a drawing also waste my time. They have want to clarify. They don't have the software. They don't have anything to can view. They only have my hard copy. Then they ask me to open back again the drawing, open back the 3D and show them here, there. Roughly every day they come in just for 2 and 3 hours. I spend time to clarify again. So I found this is a problem also. They come back to me. Then okay, let's say it's good they come back to me. What if they don't come back to me? Some of the department they feel that always I come back to you. Okay lah, I don't want to come back to you lah. I just refer to the drawing. Whatever can design, whatever the drawing had mentioned, then I do. If no do, then I assume lah. I just assume. Then after they assume the product come out is wrong, then we have to rework again. Then this is the time to starting firefighting. Who is problem? This problem. Every day also problem. Means I come into this company, I work because I have to facing this non-issue problem. It's a problem, everyday problem. Okay. I share the next cartoon. It's a cartoon. This happened, but it's not. This is a joke Okay, something like we give a drawing. We have a balloon. I believe here all the engineers understand what is balloon. Balloon is indicate the BON number, but some of the production people, they don't care. They just refer on. They don't have any experience. Some production, they are labor worker, foreign worker. They just new join. They don't know. So they open my drawing. They see balloon. Then something like this happen. This construction, they hanging real balloon inside. So if let's say our engineering department, whatever we design, something is not related to the part, but we expected the production people have the experience to understand my drawing. But find out they just refer, they don't understand. Sometimes they understand, they just continue because your design is like this, I refer on it. So how to solve this issue? How we want to eliminate the issue? How we want to reduce the time on this design 2D drawing? Because it's really waste time. Some company, yes, they hire a drafter. Is that drafter continue? The drafter experience how to understand your drawing. The drafter still come back to you, still come back to the designer. Hey, can you show me how to plot point out this dimension, which dimension I need? Finally, I find out that I do myself better than I ask the drafter to do. So today we're gonna talk about MBD because a lot of engineers today you are doing traditional 2D drawing, a lot of dimension. Because your 2D drawing, why you need so many views? Because you want to make sure your production department is doing accurate, quality product out, no rework. Then you also need this drawing many view with the datum, with the tolerance, GD&T. Yes, it's doing GD&T, and then your inspection department, the QC department, they can use your file to know each area, each view dimension. And today MBD is actually drawingless and paperless. Drawingless means we use one drawing have a many view and easy to point out every dimension. And paperless is, let's say your production or vendor do not need any hard copy anymore. If let's say they have a PC, have a tab, they even get better view on your product. So how to operate this MBD, how to use this MBD. This MBD is in the SOLIDWORKS software that I understand today a lot of attendee here is a SOLIDWORKS user and also our customer. Okay, so let me pass this the present to the Jenny. Jenny will show you how this SOLIDWORKS MBD can be operated. Okay, hi Jenny.
Hi, Ken. Thank you. So thank you, Ken, for the presentation and the introduction on what is MBD. So thank you for that. So my name is Jenny. I'm the technical in JB CADVision. So I'm going to show a demo on how to apply the BMI data, which is like dimension, nodes, annotations, all those BMI data into this 3D model. Right. So before that, okay, I'm going to show you this one is the MBD function, okay, where you have all the dimensioning function in here. So you also are able to add in symbol, nodes, table, okay, inside your 3D view. So after you have captured after you have putting in a lot of the dimension inside your model, right, you can just publish it into different formats, which is like PDF, 3D PDF, e-drawing, and step file. Okay, step 242 file format is actually a step file with solid body together with the BMI data, which is a dimension, GTNT, and all those. It will appear inside your 3D model. Okay, so for your information, start from SolidWorks standard. Okay, we have the MBD dimension inside your SolidWorks, but that one is only limit to dimensioning only, right? You can see that in here is only for dimensioning function, right? But you have the MBD, then you have more abilities and more function to add on and publish function, right? Publish to others document. Okay, so we have one part here, a 3D part here. Okay, so underneath here we have the 3D view. Okay, so this one previously I have captured two already, right? All I need to do just double click to view the orientation. Okay, so this one is the overview. Okay, so in this 3D I can add on notes, for example, in here. Okay, so I just type in something. All right, I just type in something in my notes, right? So it will appear on my 3D model, right? But if I rotate it, okay, if I rotate my model, the note is always flattened to the screen. Okay, so this one is adding in notes for this inside your 3D view. So let's say, and you can make it as a library. So for example, I have a library for the notes, right? I have one over here, which is have a default notes inside my design library. So all I need to do is just drag into my model only, right? So it means you can create a lot of library, a lot of notes inside your design library. Okay, so right. So all I need to do, I just put in drag and drop only, right? And you can do editing inside this node. Okay, for example, in here, so we have a material. Okay, so I want to link this to the custom property of my part. Okay, I just link it to material. Okay, so now it will state over here. This is the material properties, right? Follow your model, right? Let's say in future you want to change this, the nodes will update, okay, because it linked it to your custom property. So I have add in a nodes over here. Okay, so if I go to the ISO view, so the view will be disappear. Okay, it only show in this overview 3D view. Okay, so next is okay on this ISO view. So at the top of it, we have a annotation view, right? So we have left, back view, top, front view. So all this view actually is referring to the orientation, the view orientation of your model, right? For example, we have this top front view, okay, for example, like this one, okay. So this front view is actually referring to the view of this front, right? So if I go to the top, right? So have top view. So this view is actually referring, it's exactly same like this view of the inside the annotation, right? So in here is based on the orientation of your model, right? So next is I'm gonna to put in dimension inside my 3D model here. Okay, so under the MBD function, we have this auto dimension scene, which is I can recognize dimension all the feature and apply in all the dimension in automatically. All right, so in here is we have the setting here. So on the tolerance type, we have plus minus or with the geometry, which is the GTNT symbol. Okay, at the bottom side here, okay, we have option to select datum. Right, the first one, I just show the datum of my model. The bottom surface as my datum A. Right, the second one is over here. I select this surface as my datum B. The third datum is over here. Okay, I select the hole behind Okay, so we have 3 datum setting inside here. Okay, so you can call out all the dimension for inside the all supplier. So we all feature. Okay, inside you can call out everything for this all feature here, all with selected, right? Which is, let's say I just want to show dimension in here and in this feature hole, right? These two. Okay, so it will come out the dimension in your 3D. Okay, so you can see that you have the datum A, the tolerance. Okay, we have the hole diameter with the tolerance and GD&T symbol for the hole. So now it's appear in a different view, okay, in the 3D view. Right. So let's say I activate this top view. Okay, so it only show the dimension in top only, right? If I go for front, so it only show the dimension in front only. Okay, so it's according to the view. Okay, so now I go for the top view here. Okay, so we have the GTND dimension here. Okay, so we have the DN expert to show all the annotation, okay, the surface, the datum, the dimension inside here. Okay, so we have the, okay, I rotate in 3D. Okay, so this one I can call out the basic dimension of this geometry. So now we have the dimension for 12 in between the hole, 10 dimension in between the hole. All right. Okay, so now here is appearing in top view. Okay, so now these two is appear in top view. Okay, but we have others dimension too, which is, okay, we have 3 over here stated in between the hole and the surface. So we have 4 dimension here, but these two is appear in different view orientation. So now I can just simply click it and change the orientation into top. Okay, so now it will move it to the top view. Okay, all I need to do is just, okay, arrange properly on the dimension. Okay, so I have this top view with dimension ready. So next is I want to capture it, which is capture in 3D. Yep, this one is for top. Okay, the annotation view, I just want view in for top only, right? Okay, for this. So now we have the top orientation in here. So if I go for the ISO, so it will show in isometric. So if I go for the top, it only show the top view with the dimension. So I've done for the top, then I go for the front. Okay, so this one I have called out the dimension just now on using the auto scene dimension. Okay, so now I want to call out the distance from the hole to the bottom. Right, we have the GTNT over here already. Okay, so all I need to do just call out the basic dimension. Okay, we start from the hole to the datum. So we have the basic dimension. Then just capture it. Okay, so I capture to the front. Okay, so I have the dimension belongs to the front. So next is I would like to add on more dimension. Yeah, I use back the auto dimension scene. Yeah, so this time I use the plus and minus tolerance type. Okay, so the datum is referring back to this one, the datum B. Picture is the hole over here. So okay for that. Okay, so we have more dimension in this front view. So we have the whole dimension, okay, and the degree, and this one is the diameter. So we have all this already. Okay, so inside the SOLIDWORKS MBD, we can add in new annotation view. So let's say in here, I insert a new annotation view. So in here, I just select a new front, okay, a new front orientation. So we have an option to choose what kind of dimension, okay, attached to this new view. Okay, so I just attach this one, this one, this one. Okay, these three inside this new front view. Okay, we have front one over here. Okay, so and this is only with the dimension I've selected. Okay, so we have front. This one is just now the original dimension. Okay, with this, so you can create a lot of view and select which one you want to put in inside your 3D view. Okay, and then just capture it. Okay, so we have this. I just rename it to whole dimension, right? So it detects this is the configuration. So this one is front one. Okay, so I have this, and this one is just now. So all this view is just double click to activate. So next is, okay, I've done with this front. Then I go for the right view. Okay, just now the dimension I put in is using auto dimension. Okay, so actually you can able to do it manually, which is we have the rotating dimension for linear. Okay, linear dimension distance. We also have size dimension is for like hole, radius, chamfer, and this one is about basic. Okay, even you can create datum like GTNT manually. So I just go for the basic linear dimension, right? Okay, so all I need to do is just select the surface. Okay, select surface and surface. So we have the dimension inside here. Okay, so I want to dimension another one here for the distance, the height, and the thickness. Okay, just choose and position it on it. So I have another one, which is the distance over here. Oh, sorry, it's over here. So here is showing the thickness of this dimension. Okay, so now I'm able to see the view behind. Okay, I need to hide something, which is the front one. Okay, so now it's only showed you the right orientation. Okay, so this plus minus value, okay, we have by plus minus value for all the dimension here. So this one can be changed inside your system option. Okay, I go for the system option. We have the DIN expert standard means you can define all your company standard, your tolerance standard inside this. So you can just set all the standard according to the function, right? For the distance, angle, you can set all inside here, so that when you apply in, and it will automatically comes up, right? For example, in here, okay, we have the option to choose, like you can set it to bilateral, symmetry, or general. Okay, even you can change in the value. So inside here, for example, the radius, okay, I can set to general, which is without any tolerance. Okay, for the radius. Okay, for the chamfer, we have a control for a chamfer. Let's say I just make it like general without any tolerance. Okay, you can set all this inside the system option. So next is I would like to dimension the radius. Okay, so now is appear without any tolerance inside. And next is the chamfer. Okay, So I have the dimension for chamfer and radius. Okay. So this one is just now is I show is adding default tolerance inside the system option, and even you can adjust manually. Okay, for example, like this. Okay, for this 7, you can just change into other type of tolerance. Okay, even like you can change the value here individually. Okay, so it will adjust for this specific dimension only. Okay, so I have done for this one, then just capture only. So this is for the right. Okay, so next is I go for the left view. Okay, left orientation. So actually this part is created by using SOLIDWORKS function. Okay, which is, if you can see in your design tree, you have all the feature, SOLIDWORKS feature, and inside you have a lot of sketch. Okay, so all this sketch is with dimension. You have putting a lot of dimension inside the sketch already. So, and the dimension can be captured into this 3D view. So all I need to do is like, I need to call out the feature dimension, right? Show all the unassigned dimension in the model. So this one is all the dimension from the feature, from the sketch. Okay, so now it's appear in like in everywhere in different view. So let's say I just show in left. So this is all the dimension in left. Okay, so in here is all I need to do is just select which dimension that I need. Okay, I just select this, right, the distance, okay, of this, and then just arrange it into the my left view. Okay, so in here I just hide it. Okay, all the unassigned I just hide it. Okay, I just adjust the dimension here. So this is the dimension called out from the feature. Okay, you just adjust it. Okay, and then just capture only. Okay, so this one is the left with the annotation left. Okay, so I have done for the left view. Okay, so next is in SOLIDWORKS, you can create 3D capture view in a section using the section view. Okay, let's say if I on the function, the section function. Okay, so this one is the right. I'm using the section cut in right plane. Then I need to save. Okay, I need to save this view. Okay, now I have this section view AA over here. Okay, so I just orient it. Okay, so next is I want to dimension the whole in here with GD&T. So before that, I need to on some of the function, the function inside the system option. So the GD&T, geometry tolerance, inside here we need. Okay, I want on this thing is because I need to create the basic dimension when I apply the GD&T. Okay, so first is I need to dimension the hole here. Okay, so this one is the diameter of the hole and with instant 2, okay, times 2. Okay, then I add in a GD&T symbol. Okay, I just make it a position symbol. Tolerance value, okay, diameter is according to A, B, C datum. Okay, so once I click OK for it, So the base dimension in between the hole of these two holes will appear. Okay, so it's in between the hole and to the datum, as well. Okay, so we have this. Now it's already positioned nicely. Okay, we just need to just capture it only. Okay, so we have this this view. So actually it's section view. Okay, you can see over here already cut out here. Okay, so this is all the view is actually is under same configuration. As you can see over here, the configuration manager. So all the view I've created is under the default configuration. So actually the view can be applied to different, you can create view according to the configuration. For example, like this one, I just on it the version 2. Okay, so this one is a different type of design, right? I just go to view the right orientation. Okay, I have this right orientation. So just now I've created a right view with dimension inside here, but it's under default configuration. And this can be copied. Okay, so all the dimension inside, I can copy and paste it into this new configuration, right? Okay, so from here you can see it's the same type of the dimension. Okay, so but the dimension is updated according to the model. I just capture for this. Okay, and it automatically detects this is under version 2 configuration. Okay, so we have the right view inside this configuration version 2. Okay, so we have a lot of view in here already. So this view can be published it to the 3D PDF and also the e-drawing, and publish a step file. It's a 242 format. So 242 format is a step file together with the BMI data, which is together with all the tolerance, the GD&T symbol inside your 3D. Okay, so also have the publish to e-drawing. Okay, so where you can send it to the department, to others department which do not have SOLIDWORKS. Okay, they can open up this e-drawing, right? So inside here, you just need to select which configuration, and even you can attach a step file here, right? You can attach the step file inside this e-drawing. So for example, I just open up, which is I done previously. Okay, this is the e-drawing file. So inside here, the same thing is you can see the 3D view. So in here is you can see all the view this is created, which is created under the SOLIDWORKS. Okay, and even you can see the dimension. Okay, you can zoom in to see the dimension and rotate. Okay, to see where this dimension is inside the e-drawing. Okay, like for those which do not have SOLIDWORKS software, okay, they can view this 3D and they can even see the dimension inside here. Okay, so this one is under e-drawing, and this one is the attachment that I have on just now. Okay, it will attach together the step file, and even like it can extract. Okay, you can extract the attachment from the e-drawing. Okay, so this one is the example of e-drawing. So next is I'm going to show the example of the 3D PDF here. So I show one of the example. So this is the 3D PDF. Okay, so the templates here you can customize by your own. Okay, you can put in your own logo, add in the information inside, and this information, some of it you can link it to your model. Okay, we have the notes. Okay, drawing notes inside here. Okay, we have all the view which is created in the SOLIDWORKS MBD. Okay, so the best thing here is that you can zoom in, zoom out, okay, and rotate. Okay, even you can rotate inside the PDF. Okay, so you can see the dimension here. Okay, just like we are doing the 3D. So this one is one of the example of the 3D PDF parts. Okay, so all this I do in part. Okay, you can do the same inside SMB. So I have the SMB file here. Okay, we have one SMB file here. Okay, so in here we already have a field of view which is created. I just on it. Okay, so inside your SMB you can create section view like this. Okay, so you can cut out, you see the detail inside. Okay, another example here is the section view. So you can see the section cut inside the part. Okay, so even like you can put in dimension. Okay, you can put in dimension inside your SMB. So we can create exploded view and capture it into 3D view. Right, we have already have one exploded view here. Okay, so we have this. Then I just capture it into the 3D view with the exploded configuration in here. All right, just double click to activate this one. This is captured under the 3D exploded view already. Then you can put in like bill of material inside your view. Okay, like putting into your view. Okay, I just delete this one. Okay, you can adjust the, okay, you can customize your own table. Then you just like adjust the font, the table in what kind of information that you want to put into your table. Okay, just like the 2D drawing. So we have one table together with the parts exploded view. Okay, I just capture it. Okay, so this is what we can do in the SMB. Yep, then I show it inside the, okay, when you are exporting into the 3D PDF. So the same thing is you can able to see all the view. Okay, even the exploded view. So you can view over here. So this is a table, a bill of material table for this part. So if I click on the part, it will highlight on your table. Okay, it will highlight on the table to see the description and the quantity. Okay. So this one is inside the assembly. Like even under the PDF, you can add in some of the comment over here, okay, and save it, and you can pass it over to your fabricator and your supplier. Okay, you can add in some of the notes inside. Okay, so all this is what I show is a fabrication part. Okay, actually, if you have a sheet metal part, it's applicable also. Right, for example, I have a sheet metal part cover over here. Right. So first of all, I create an isometric view annotation. Okay, show all annotation. Okay. I insert a new view, which is an isometric view. So that when I activate it, I have an isometric orientation. Okay. So in here is, I can just put in like bill of material with description. into my part. Okay, I just delete this. Right. And adding in, right, this one is kind of small. Okay. So this size can set over here or inside the system option. Okay, you can set over there. Even like you can add in balloon, right? You can add in some balloon for this. Okay, in your 3D part. So this one is isometric. Okay, we have the nodes with balloon. Okay, just orient properly, then you can capture it. Okay, like even you can flatten it. So I have a function in SOLIDWORKS MBD, which is you can insert band nodes into the flatten. So you will create a configuration with flatten view. Okay, so all the nodes like bending up, bending down. Okay, all the nodes will be appear inside a flatten view. Okay, so now it's creating a new configuration together with the view. Okay, and the nodes inside here, right? So I need to adjust the nodes. It's too big already. So everything is adjusted in the system option. It include the dimension, the arrow here, the precision. Okay. All these they can adjust over here. Okay, I just go for display. Let's say over here, 2:1 of the scale. Okay, so it's scale down. So we show the bending line. Okay, include the band nodes inside the flatten view. Even you can add in the band table. Okay. So that all the nodes is represented by ABC or 1, 2, 3. Okay, so now it appear in tag number, which is ABC. Okay, and you can adjust the size. Okay, and the table. So this one is under flatten view orientation. Okay, so you can zoom in to see this is all the ABC tag. Okay, you can link it to your table here. Okay, and the orientation of it you can change. Now it's like vertical. I can just change the orientation of this to horizontal. So I make it like rotate in 90 degree. Okay, so we have this all in a horizontal annotation in the horizontal view, right? So it means that you can get all this and then just capture it. Okay, so this one is inside the sheet metal. I want to apply all the bending annotation inside the sheet metal. Okay, we go for here, you only see the ISO. Okay, so this one is applicable to the, okay, you want to show the flatten view. Okay, so this is today my demo, which is I've showed the MBD inside the parts, in the assembly, and inside the sheet metal parts as well. Okay, so Ken, are you there?
Yes, yes. Okay, let me share my screen. Thank you. Okay, thank you, Jenny. Okay, everyone, before I end this section, so let me summarize 4 categories that today we want to bring out. Like Jenny already showed how to operate it. So how this software actually helping us in our industry, our engineering, our workshop. We find out 4 challenge actually is a common issue. It's not like just I mentioned, it's my issue, my company, my previous company issue. I think it's quite common. Even we visit a lot of company, we understand their challenge. That's why they purchase with the SolidWorks with us. They need to solve their problems, solve their issue. So for the drawing side, they have the biggest challenge. This is a survey from not from our site. It's a survey in the Google. We are finding in the Google Analytics to find out this issue. So actually, a lot of company they don't have something like the software. They don't have any platform to open your file. And just now mentioned, Jenny already mentioned, they have we have a means our MBD can convert to the PDF and e-drawing. PDF I think is free. E-drawing also free. If you do not e-drawing, you can inform us. We can help you to download. So after the MBD, actually they convert the PDF file. Normally, who is the people to view it? Normally, it's subcon. Either it's a production. What if the production they say that my production people is I don't know how to use this software, but I can tell you PDF and e-drawing no need training. They just only can view, they view, they can rotate. It's a very easy to use it. Okay. The secondly, supplier and consumer always have additional clarification. The problem always they come back to me, they find me because the detailed drawing is not accurate or some of the dimension is not point out. So in this MBD, it's a fewer clarification because we are one drawing already mentioned every dimension, and even the people when they receive your file, your PDF file, they can view easily, they can rotate it in the PDF. They also can see the each dimension. And this is, I think this is very common issue in JB that I face in our customer. Recreate 3D model. Normally, my customer, a lot of let me know that they receive a lot of 3D file is a native file, something like IGS or STEP. Very hard to do a measurement. Then they receive a hard copy, or sometimes it's a good they receive a PDF with all the dimension. It's not good they receive a scan copy. Something a scan copy maybe it's an old version, have a revision. The customer or some others they give them the hard copy with use handwriting on the PDF and scan to them. So that's why our customer has no choice. They have to recreate the 3D model again. To recreate, they spend the time to recreate because they need the dimension. To before go to production, they worry about anything happen. So finally, this all the thing is resulting all the scrap material. Then they have to rework again. So this all 4 challenge keep coming every day, coming again. So this MBD, today we present this MBD actually is to solve this issue. We are not 100% to solve it, but we streamline it, optimize it. We help to reduce the percentage chances to do mistake, to fewer the clarification, don't need so much additional clarification. And even your production and subcon have a very detailed drawing, very clear drawing. Just like since sometime our customer I have proposed this MBD, my production side they don't have PC, they need hard copy only. I think this is a new trend for a company that actually this is running very good in Aero and also in China. So why not in our Malaysia? We are starting to grow. We are follow the trend. That's why our platform is starting. We need to set up a one screen or PC. It's not expensive for hardware. So anytime you just send the PDF or 3D drawing email to the production, you don't need to ask them. We can save the paper. We don't need to print out a lot of paper. We just say to them that anytime they can open in the PDF. Anything, if you got OT in the production, sometimes engineer is working after 6, then back. The night shift, they need to clarify the additional clarification. They don't need to call to the engineer in the night time. They can even make a decision themselves because they have a very clear drawing. Okay, so everything from here actually is reduce all the final rework, the scrap material, the wrong product out. That's why they know if no rework, then no delay. Your project is on time. Okay. So I think today my presentation is the end here. So if any question, anyone has question, you can raise here now. I think, have anyone any question? Okay, if no question, I think we can end here. So later we will send a feedback to your individual email, and we are trying to contact to you and to help us to feedback whether this MBD function or this MBD system, whether it's helpful to you. So the question is over there later. Okay, thank you very much for today to joining us. So in any others presentation, we will invite you again. Okay, thank you very much.
Hello，大家
Hello，
听到我讲话吗？
听到你的。哎，sorry，刚才
听到了
我电话我没有发觉到。
对，不用紧，还 OK， 还 OK， 可以 OK， 这样我就briefly按这个我们的今天的 MBD 啦哈，所以我们今天 total registration max 是有24个，等一下我 share 我 screen 一下。
就是 attend 的有24个。
对，有 attend 的是有24个 from 27。等一下